Hello and welcome to the 54th lecture in the series of Knowledge Miles webinars, part of the Lord Mayor's lectures on behalf of Professor Michael Bonelli, whose theme for his mayoral year is Connect to Prosper. In this series of online lectures, we address the connections in and around the square mile of the City of London, connections which can and are helping us to tackle the challenges facing the world today. I'm Dr. Kevin Parker, Director of KKI Associates Limited and Science Advisor to ZN Group in the City of London. I'll be chairing this session and taking questions and answers afterwards. So this is the plan for today. A brief introduction, a keynote presentation from Matt Wills, and then about 20 minutes of questions and answers. You can either use your microphones or send in questions using the webinar software. Just to introduce what we're talking about today, the session is going to explore the current state of sustainability in what is humanity's latest operation environment. I have a godson who is busily a space scientist at the University of Aberystwyth. He's busily sending materials up into space. And what that means is space debris poses a significant threat to large swathes of our economy. The space interest is seeing growing interest in understanding space sustainability. The new space economy is poised to launch thousands of satellites into our orbits, and current sustainability strategies are limited to mitigation. Matt is going to explore the potential to open a market to fund the removal of existing debris. His career showcases experience as a systems engineer and an explosives engineer in both the civil and private defense and aerospace sectors. His work has focused on the adoption of novel technology into new domains and highlighting new markets for businesses to exploit their capabilities. His work has most recently been drawn to the sustainability of our operations in orbit and power generation for future space missions. Currently, he's co-founder of Sustained Space. He's pioneering efforts in space sustainability, developing innovative funding models for space debris remediation. His expertise positions him as a key innovator in creating a sustainable space environment. And with all that, I'm going to hand over to you, Matt.
Wonderful, thank you. Let's share my slides. Can you see that? Hopefully. Wonderful, great. Yes, thank you. Thank you for the introduction. Thank you for having me. So yeah, my name is Matt Wills. I am the co-founder and CEO of Sustained Space. We're a small startup looking to fund the remediation, the removal of existing and what will be future legacy debris. So what I want to do today is essentially talk initially about what space debris is, talk about some of the numbers and why we care. And then I'll go into what we want to do with the offset market. So I'll start off first of all, space debris. What is it? It's the non-functioning stuff that we've put up in space. It can range in size from sub-millimeter scale all the way up to multiple meters, multiple tons in weight. And it's flying around in orbits at tens of kilometers a second, and that means that even the tiny stuff can be incredibly damaging to our assets in space. So there's a famous photograph of one of the windows in the space station that has a big old crack in it that looks like someone's shot a pistol at it or something like that, and that was just a tiny little paint fleck hitting it. So what have we put up there? It's quite a lot, and it's going to be a lot more in the future. There's been about 6,500 launches, putting around 17,000 satellites up, and 9,000 of those are still up there and functional. So that's the numbers on the left there. The problem is not all of it is easily trackable, traceable. So the big stuff, yes, easier to follow. The tiny stuff, we have to estimate how much is actually up there. So that 1 to 10 centimeters, there's a million debris objects. That's an estimate. We don't know exactly. And the number there at the bottom says that we track around 35,000. There's different estimates about how much we actually track. It's some say around 40,000. But what I find interesting is that the third thing we ever put into space, Vanguard 1, is still up there and will be up there for another 200 odd years. That gives us an idea of how long stuff stays there. And I pick out this quote because it tells us a little bit why we should worry about space debris. And it's from Chris Hadfield, who's an astronaut. He said if you sit quietly on the space station, you can hear things hitting it. That should worry us. If our manned spacecraft up there are getting hit by space debris, there is genuine risk to life up there as well. So why do we care? The average person on the street probably won't realize how much they rely on space and how often they actually interact with space. So you use your phone, you watch TV, chances are part of that operation might go through space via satellite. If you look at the weather forecast, that will need space satellites. If you care about climate change, most of our data on climate change comes from space. The military, of course, uses it to track and communicate. Our financial markets use it to get their timings. And of course, there's the go-to GPS. I imagine most people nowadays probably can't read a map because we use GPS so much. But our flights, our maritime industry all rely heavily on GPS. So there's some numbers there. It says 17.7% of UK GDP is dependent on satellite services, and if we were to lose satellites, it would cost us around 7.6 billion a week. And that losing satellite statement is a sort of nod towards something called the Kessler syndrome. So that is the idea that if you have one collision in space, it creates a cloud of debris that continues round and hits other things and creates further debris, and you just got the cascading effect of increasing debris and increasing clouds around Earth. And there is the potential that it becomes an inoperable environment in future, and we lose access to space if we don't do anything. So we need to start cleaning up, essentially. So are we keeping it clean? First of all, I want to draw attention to the graph on the left. So that looks at what is up there. Is it maneuverable? Is it just stuff, objects that we can't necessarily categorize, but we know are there? You'll see that spike around, and this is just for low Earth orbit for context, up to 2,000 kilometers. That spike around the 600 kilometer mark, that's Starlink. That's that massive constellation that's up there. So we will be seeing more spikes in future as further constellations go up. But yeah, Starlink are good. Well, I say good. There's a lot of them, but they operate quite well. They prefer to make themselves maneuver to avoid collisions and things like that. So that's good. But what you'll see at the top is that orbital lifetime section. That's telling us at the end of life of the satellite, once it no longer functions, if you did nothing, how long would it take for that object to come down through the orbits and burn up an atmosphere? So for Starlink, it's around 5 years. But if you go up to 750, 850 kilometer orbit, those are quite cluttered with objects, debris. It's very dangerous up there, and the stuff up there takes around a century to come back down. You go up to around 1,000 kilometers and you're talking about a millennium. So we need to actively do something to make those objects come down faster at the end of their life. So that's called post-mission disposal, PMD. And there are guidelines around that. So European Space Agency, ESA, they've got their guidelines. The UN has their guidelines. America has their guidelines. And they're not necessarily enforceable guidelines, but they can say that we won't give you a license to launch if you don't remove your satellites at the end of life within 25 years for the case of ESA and others, 5 years for the US. Likely that everyone will tend towards the 5-year line. But you can see from those graphs that only around 50% of satellites in low Earth orbit were removing themselves, were successfully doing a post-mission disposal operation at the end of life. It's getting better though. In the past couple of years, we are doing better than 50%, luckily. Rocket bodies, is that graph on the right, they are more likely to dispose of themselves because they tend to go only to lower orbits and release other stuff. So we need to really start pushing to improve those post-mission disposal operations and be more successful in that sense. What happens if we don't achieve those guidelines? So I think the first point I need to stress is that if we stopped launching things into space today, if we said, right, enough, let's just leave it, you would still see an increase in catastrophic collisions on orbit. Now, that is why some people say that we've already passed into the Kessler syndrome. And what that says is that we need to start removing things. We need to start removing those non-functioning debris objects. The two graphs on the right here look at if you achieved 90% post-mission disposal or 99.5% post-mission disposal. That's what those different lines tell you. So PMD 90 is 90% disposal, and then 25 is remove yourself within 25 years. That says that even if we do really well, much better than we're doing today, we're still going to see an increase in objects in space, and we're still going to see an increase in catastrophic collisions in space. And what's important to know about this is it makes the assumption that all functional objects in space successfully dodge things. Now, that's not necessarily going to happen in reality, and it's also hard to estimate what happens beyond that first impact and that cloud that's created and what it then goes on to create. So what these are most likely an underestimate of the impact of space debris and the growth in space debris in the future, especially now that we have potentially 100,000 satellites going up in the next decade, and there's requests for licenses for over 1 million satellites, or sorry, requests from the ITU to get over 1 million satellites. Most of them won't happen, but still, it's worrying to see this coming about. So what we need to see here is that there is a need to remove existing debris, legacy debris, as it were. The problem is no one can agree who pays for it. So that's what we at Sustain Space want to do. We want to make it possible for people, for the space industry, and a very valuable industry at that, to pay small amounts each and collectively fund the remediation, the removal of existing debris. So where do we fit? What we want to do is create an offset market. We essentially say that you can track debris, you can estimate how much debris your mission will contribute to space, and you can get an average cost to remove debris, put that together, and you've got an offset cost. We sit outside of everything else that's going on. So first of all, you've got your mitigation guidelines. This is like what I alluded to earlier, and saying remove yourself within 25 years or 5 years. There's numerous guidelines set by numerous bodies, and one of the ones just coming out, people are signing it, is the ESA Zero Debris Charter. And now zero debris doesn't actually mean zero. It means maybe a little bit more than zero, because they asked for a target of 99% success in post-mission disposal. It's a very difficult target. What those guidelines do is sort of inform people what they should be doing. And then we go down into the standards and the scoring mechanisms, which is something called ESSI, Space Sustainability Initiative. Their standards are coming out at the moment, and they've collated all these guidelines and said, right, if you want to be sustainable and achieve a sustainable standard, this is what you need to do. So that's been a very large, very important piece of work that's it's coming out at the moment. And so there are now people to say, okay, I know what I need to do, this is how I do it, and this is the standard to achieve. The next thing, the space sustainability rating, is another way for us to sort of shout about our successes and say, okay, we as an industry have got, as a satellite operator, or I've applied for my SSR, I've got a bronze rating or a silver or a gold or a platinum. And they will allow you to go, okay, I'm a sustainable, I am a responsible operator. And then once you've got this standard, you've got a rating, it can inform things like insurance premiums. If you're shown to be more sustainable, you might get a lower insurance premium, for example. And what those might do is sort of help us mitigate the creation of future debris. The other side of it is there's potential space bonds coming out. So I'm down in the future debris removal funding section now. Space bonds are a mechanism being looked at whereby you would pay into the bonds, and if your satellite were to fail at end of life and you cannot pay for its removal yourself, the bond might cover an amount to actually pay for a mission to go and remove that object. You get an active debris removal, an ADR company, to go and get that object that has just failed. So all of those I see as mitigating the creation of future debris, where you're essentially saying, okay, I'll try and do my best, I'll achieve the standards, and if all goes wrong, I've paid into the bonds, so at least it won't be debris because it will be removed. What we do is sit just outside that and we say, well, there's still going to be stuff that's created. There's still going to be debris up there that won't have a plan for removal. It won't have the space bond to go and collect it. It'll become legacy debris. And we need some way of paying ADR operators, active debris removal operators, to go and get that stuff and remove it. Anyway, yeah. So how the offset is calculated. This must be done in collaboration with industry. So I'm not going. So the stuff on this slide is more for this early discussion. It's not hard and fast. This is how it's going to work. But what we would expect is we create this average satellite, and that essentially says that over the past year, the satellites that have gone up it's this mass and it's got these level of sustainability credentials. So it's got a standard, it's got the SSR rating of silver or bronze or something like that. And we can say that the mass of debris in space has gone up by this much in that period of time. So you can say the average satellite creates or contributes this mass of debris to space. Then we can get an average cost of ADR, active debris removal. That comes from the ADR operators. They'll say, oh, it's maybe 20 million to remove your average satellite. Okay, great. Well, you've got your average satellite, you've got your average cost. So the average mass of debris a satellite's going to contribute. You've got your average cost to remove debris in space. You've got your parts of an offset. So a satellite requesting an offset would come to us at Sustain Space and say, how much does it cost for us? We compare their mission, their satellite, to the average satellite and say, right, you are smaller and your sustainability credentials are better. Therefore, you will contribute less mass of debris to space. Based on the average cost of debris removal, your cost to offset to remove that mass of debris that you would statistically contribute to space is this. That's your offset cost. That offset cost then comes into a trust that we manage. So that's the next slide. So what we then do with that trust grows when you get enough operators paying in to the point where it can fund active debris removal missions. And there would be a register of debris objects, which I'll come on to in a second. And then the top object on that register, we put a tender out, say, debris removal companies bid to remove that. We'll choose the best bid. They go and remove the object. That then gets verified, and we say, great, you removed 500 kilos of debris from space. And we say, okay, a kilo of that was paid by this company. 2 kilos were paid by that company over there with their offset. And you essentially go around that over and over and over again, removing more and more objects from space. So this debris register, how we decide what gets removed from space is going to be it needs to be agreed upon by everyone who pays into the offset, because everyone's got their own personal preferences. So the register would be populated by debris objects whose owners or responsible nations have said, we are happy for this to be removed. We will let active debris removal operators from whichever countries go and get this object. Those objects go into the register, and we can give them scores based on what orbits they're in, what orbits they pose most risk to, what the cost of removal might be, what the chance of success of that mission might be. And then those who have paid to offset can submit their preferences for what is removed first, in terms of, do they want it to be the object that poses most risk to their orbit, or they want the lowest cost to remove, or they want the highest chance of success of the mission to be removed first. And when you've got those operators who have offset submitting their preferences into the register, you can start ordering the register, and it's essentially a voting mechanism that says, okay, after a while, the top objects, the one that we have now got consensus on, is the one we need to remove first. Great, we'll go and get that one, carry on. So the overall process, yeah, satellite operator comes to us, gets the offset cost, they pay it into a trust, which we'll manage. We register that they've offset. They can go and get their incentive from whoever's going to provide their incentive, most likely government. It might be anything from, I don't know, loan insurance premiums, or it might be the greater liability that the country will be happy to take on. And then they can go and launch their mission. We then operate the register, operate the trust, find the active debris removal companies that will go and remove the object the register has highlighted. They then pay for it. We verify the removal, and then we carry on. And we keep going around that over and over and over again. So what impact does this really have? Well, I mentioned earlier about how debris guidelines, this is zero debris charter. It's not net zero. It's not actually zero. What we are doing with the debris offset market, we hope to do with the debris offset market, is make it such that we can get zero, actually net zero debris in space, because we'll be removing legacy stuff. So yeah, you've got your guidelines. That's the first hurdle. They tell us what we really should do. The standards and the rating systems then tell us how to do it, and let us sort of shout about our successes and promote ourselves. In a sense, sort of compete to be the most sustainable in some cases. Sorry. Then you've got the post-mission disposal fundings. That might be space bonds or similar. They help us sort of mitigate by removing future stuff. And then the legacy debris disposal funding, that's what we see as the offset market. That is our last small hurdle to achieving to net zero space, net zero debris in space, and potentially even net negative in the future, which is ideal. And as you decrease the amount of debris in space, the risk comes down, your insurance premiums come down, the cost to offset comes down, and it all goes around the cycle till eventually the offset market doesn't need to exist, because we are so good at post-mission disposal, we're so sustainable in our operations. But that, of course, is the long-term goal. And yeah, of course, we can be optimistic and say we'll get there in the short term, but yeah. So that's us. That's sustained space. That's what we want to do with the offset market. That's where we sit, and how sustainability sort of is currently going. And I am happy to take questions on any and all of this. I may have gone slightly under time there.
That's great. Well, okay, if viewers would like to write questions in the question thread, that would be great. Matt, I'd like to kick off. So you were talking about these missions, basically to go up and collect the data or dispose of the data, and I think you used was it ADR?
Yeah.
How many? I mean, firstly, gosh, that sounds incredibly difficult to do. So how is it done, right? And because I'm thinking of, gosh, we're sending up rockets which have boosters and things and that fall off, and how do we make sure that those missions don't create more debris? And the other is, how many are there actual companies or organizations planning on doing this? Are they all ready to go and just waiting for the funding? So can you give us a bit of a background on the kind of the technology and the opportunity?
Sure. Yeah. So in terms of how it's done, there's a few different methods that have been proposed. So the really, really small stuff, you might be able to slow down with a laser from the ground.
Yeah.
The larger objects, there's one company called ClearSpace who've got this sort of robotic arms that wrap around a satellite that then hold it, and they'll bring that down. There's Astroscale who have docking plates, so that's more if you've paid to have a docking plate put on your satellite, then they can go and get it in the future. But also they're looking at other methods of interacting with robotic arms and grabbing and holding. Harpoons have been tested. Nets are another option. But in your question, you touched on, yes, there is a risk to create more debris in doing so, and that's why one of the key hurdles to this is the advancing technology, RPO technologies, rendezvous proximity operations. That is essentially getting close to stuff and being able to operate around it safely before you capture it. Now, there are a couple of missions going on to do that. So Astroscale recently had a mission where they managed to get close and image a satellite that they're going to interact with. So that's one of the first sort of major steps. There's a couple of missions already being developed to go and remove objects. Interestingly, ClearSpace had a mission to go and get an object called Vespa, but Vespa got hit by debris, and so they couldn't then go and get it. So they've had to change their target. So I mean, it's quite useful for the cause of sustainability to say, look, our debris is getting hit by debris. So yeah, that's what the companies that are looking to do. Astroscale, Clear Spaces, Cal Morris in the US. There's I think there's even a company in the US called Space Cowboy who wants to go and do it as well.
With lassos or something.
Absolutely, yeah.
Yeah. And the debris is this is not geostationary orbit. This is all of this is rocketing around the Earth at sort of 20,000 miles an hour, and presumably not all of it going at the same speed and pace, which is why some of it even going in a different direction.
Yeah, different orbits, different directions. A lot of stuff goes around over the poles.
Yeah,
So there's a lot of crowding over the poles. So that's
yeah.
where you're likely to get a lot of impacts. Yeah, there is debris in low Earth orbit. There's debris in medium. There's debris out in geo. It's everywhere. The most congested area is of course low Earth orbit, where there are the most satellites and most sort of collisions have happened.
And I imagine you've got a kind of nasty bit in the middle. You've got some very large bits of debris which you can see and spot. You've got some tiny bits of debris which just make scary noises on the space station. And then where's the real danger? Is it sort of pea-sized bits of debris?
So anything from a centimeter up can really cause damage to a satellite. I mean, even sub-millimeter scale, if it starts hitting your solar arrays, if enough hits it, it'll degrade your power generation
Yeah.
capability. So that might end life for the satellite. But yeah, the large objects colliding that create thousands of pieces of debris when they do collide, that is what is really risky. But we do track a lot. And there are conjunction warnings, which is essentially goes to satellite operators to say something's going to come within a kilometer or two of you. You might want to move. But even despite having those conjunction warnings that go out, we get very close calls. In the past few months, there have been a couple of instances where they come within tens of meters of each other. And tens of meters, when you're traveling 10 kilometers a second,
Mm.
is a fraction of a second that you've missed. You've got incredibly lucky there that there wasn't a collision.
Yes, your closing speeds could be that's sort of
Right.
30,000 miles an hour, couldn't it? Yes.
Yeah, absolutely.
Okay.
Yeah, and you just create these two clouds of debris that go in opposite directions and interact with whatever's in the way.
Right. Yeah. And this is all tracked by radar.
Yeah, so US military tracks a lot of stuff. Well, various militaries track a lot of stuff. There's companies like Leo Labs who have set up tracking stations, and they're actually increasing their capability. There's a lot of market in most of the market for debris removal and tracking actually sits in tracking. I think 75% of the funding goes into tracking and space situational awareness. Only 25% goes into actually removing stuff.
Mm-hmm.
And that's because there isn't really a market for removing stuff in the future. As I was touching on earlier, there needs to be an incentivized route for people to follow to actually pay to remove stuff.
Mm-hmm. Mm-hmm. So, what do you see as the main obstacles that for your plan, your organization? Getting buy-in?
Sorry.
Is it getting buy-in from all the interested parties and stakeholders?
Yeah. So active debris removal operators, I mean, they'll love the idea because it pays for them in the future. They like it. Governments, it helps them because at the moment, satellite debris removal missions tend to be paid for by governments. They tend to be the responsible people, and so stuff like this, an offset market takes the cost onto operators instead. Well, as well as the international governments. But incentivization is one of the real hurdles because satellite operators right now, they don't have to do this. They don't have to pay. They don't necessarily have to remove themselves. Their guidelines are not stuck in law. You can actually do jurisdiction shopping. You can go and license your satellite somewhere else that is more lenient when it comes to sustainability. And so you've got to make it such that companies will want to offset themselves or achieve the highest standards in post-emission disposal because they will get lower insurance premiums, for example. They need to make sure they are either making money or not losing money by doing this because they need to be sustainable in their financial operations, really, don't they?
Right,
And
we
the
have
other
a, yeah.
side, sorry, just from the government side of it, when they do incentivize it, they need to make sure that, yes, they put in these sustainable practices and requirements for it, but they don't do it in such a way that it drives business away. So there is a balancing act to do there.
Okay. We have a number of questions, a good number of questions. I think you've answered some questions. Leslie Morgan was asking about how successful removal has been. Nikki Holtzhausen is asking about which companies have successfully removed debris from space. I think we've covered some of those things. We have a question from Tony Turner. Tony says it might be cynical, but if insurance companies are involved, won't there be squabbles about the risks from man-made objects versus various natural bits of rock? I'm sure insurance companies never act like that in real life, but that's.
I think they focus more on the interactions of man-made objects in space. If yeah, yours. So they will cover things like well, it's generally the loss of your satellite. And yes, there might be solar flares that might mean your satellite no longer operates. And recently there was a very large solar flare that hit Earth, and a lot of satellites, I think their orbits lowered because it grows the atmosphere, everything slows down slightly, so they had to do some raising stuff. Yeah, insurers, I think, are they're in a difficult situation at the moment because they've just had a lot of high cost claims come in. I think hundreds of millions in the past year or so. That means that space itself is not necessarily a good environment for insurers at the moment, but in the future it might be if we start operating more sustainably. So I think they're trying to figure out how best they approach incentivization of sustainable practices, how best they do offer premiums and what they set those at, because it can't get to the point where people aren't insuring themselves. But at the moment, very few satellites in space are insured past their first year of operations.
Okay. Can you give us an idea? I have a question from Sergei Pisetsky. What's roughly the cost of removing a kilogram of space debris?
So the average mission cost, I suppose, is around 20 million. Well, that's what they aim for.
Yep.
So that is in the long term. Right now, the missions being developed, they cost around 100 million, but they're development missions. They're going to cost more. In the future, yeah, when it comes down to 20 million, I suppose around $50,000 a kilo ish. But then there's scope for active debris removal missions to actually remove multiple objects. So Astroscale and I believe ClearSpace are working on. They send one satellite up, it'll go grab a piece of debris, move it down, let go of it, let that go and burn up. Then they'll go get another piece, and then they'll grab that and bring it down and burn it up. I think the aim is maybe 4 or 5 pieces of debris in a single mission, and doing that will reduce the cost. So right now, a development mission is of the order of 100 million for a 200, 300 kilo satellite.
Yeah.
But yeah, in future it will be. They do aim for around 20 million for the average satellite, so that equates to it's around 50,000 a kilo.
Yeah. Okay, that's good. Someone has asked whether these slides will be shared, and I can confirm that they will be shared. You're happy with that, aren't you, Matthew?
Yeah, that's fine.
Good. A question from Sukratu Anil Baba. A wild idea. Has there been any thought on recycling the space debris? Are
Yeah,
we just bringing it down to destroy it? Isn't is it not useful? Um,
yeah.
could you
So
put a recycling station in low Earth orbit?
long term, we should not be burning things in the atmosphere. It's
Yeah,
damaging our atmosphere already. There have been studies looking at uh, particulates in the upper atmosphere, and they found there are metals that are only you can only say that they've come from space operations. And so we are polluting our atmosphere. We're potentially destroying the ozone in doing so. And as we have more satellites going up there, that's going to get worse. So you need to start doing something else. Send them to graveyard orbits, or yes, recycle and repurpose. So
yeah.
what this is touching on is something called is the circular economy. And the circular economy in space is something. It's a new, fairly new topic for us, but there's a lot of interest in it. It is difficult to recycle in space. Not all materials are recyclable. Plus, you'd have to have a safe area to do it in. So yes, there may be a recycling station that people can get their satellites taken to in the future, and it might pull apart a satellite and use certain materials again. We are manufacturing in space. That exists already. There's a company called Space Forge which is looking to manufacture in space. That's a very interesting one. And so we've actually done printing in space of materials. So those could take that recycled material, potentially extrude it into fibers that you could then print with. This is a quite a long way off though, unfortunately. Um, Hopefully in 15 years or so, 20 years, you might see beginnings of recycling, but we'll also need the satellite industry to start designing their satellites to be recycled. So make them more modular, use similar materials, make sure they can be pulled apart safely, all that sort of stuff. So it's not a wild idea by any stretch. It is thoroughly in consideration throughout the space industry. It will become a thing. It's just it'll take a while.
But the missions that have been so far have been grabbing bits of debris and bringing it back down, or
Yeah,
letting
so nothing's actually been grabbed and brought back down yet. It will. These development missions are looking to go up in the next year or two to go and grab something and then remove it down, and then burn up in the atmosphere. But yeah, right now we have not. I don't think we've actually done successful active debris removal missions of legacy debris.
Good. I have a question from Nikki Holtzhausen. Basically, can you tell us, could you indicate whether any insurance or space bonds have been provided to date? Is this we're nascent? Where are
Still
we in this process?
Still figuring out how they'll actually work. In terms of debris removal, still figuring it out. Insurance premiums already exist for satellites and launches and things like that. But methods of funding debris removal, we are trying to understand what should work, what could work, and what will do the best job. I think what we'll get to is everything will play its part. So space bonds, for example, might they'll pay for removals, but again, it's only removals of stuff that have paid into bonds initially. We see the offset market as a means to remove the other stuff that exists that has no plan, and that the number of those objects that exist and have no plan for removal, that's going to keep increasing until we start removing them. So yeah, at the moment, everyone's trying to figure out what works, what could work, but I expect that it will be a number of different mechanisms in the future that come together to do it.
So are we then looking at this whole area will evolve over the next 5 years, 10 years, 20,
I'd
30
hope
years?
so. Yeah, I think that um, it's going to be a difficult one for satellite operators to take on initially because you'll have to start changing your missions. And I know that they've got years of practice of developing satellites without these sort of sustainable requirements necessarily. So I think what governments need to do is reward those who are sustainable for the first sort of 10 years. And then after 10 years, those who aren't sustainable, they've had the time to change, they've had the time to adapt their practices and build these sustainable satellites. If they're not doing it, then they'll probably start getting a slap on the wrist for not being sustainable. There is now precedent actually for in the US they fined a company that did not remove its satellite as it said it would, The fine was only around $150,000. That's pocket change to the company, but it's a nice precedent to have been set.
Good, great. And I'm not seeing any more questions at this point. So, Matt, thank you very much. I will say that all the slides will be available. It's an interesting, fascinating topic, and I'm sure we are willing to engage with people in the City of London.
Yeah, absolutely. And if there are any questions later on, happy to take them. I'm on LinkedIn. You can find me, send me messages. I respond.
That's fine. Thanks very much. Just before we close, I'd like to tell people about forthcoming lectures. Thursday, the 13th of June, that's tomorrow. We will be hearing about embracing our multilingualism, why languages are for everyone. Next Wednesday, Seeing is Believing, the miracle of modern eye health care. And then the Wednesday after that, Maths for All, the importance of maths literacy. So over the next 2 weeks, we'll be improving our skills in both languages and mathematics, thanks to these lectures. So I think that's all that we need to do at this point. And thank you, everyone, for attending. Thanks, Matt, for giving the lecture, overcoming the sound problem, and answering all the questions. I'm not seeing any further questions, so I think we will close the webinar at that point. And thank you very much to everyone.
Thank you for having me.